Hi, if you're here and you're watching this video, that means that you're looking for some AP Computer Science A-Prep. If you don't already know me, my name is Aditya Anandan. I'm a senior at Irvington High School in Fremont, California. Last year, I took the AP CSA exam digitally and I got a 5. So I think I have a pretty good understanding of what it takes to get a 5 on the exam and how you should prepare and what content you need to prepare. If you're on my YouTube channel, make sure to go check out my Thinkific course. We have practice quizzes, we have worksheets, we have practice tests, and we have these conceptual overview videos that you're going to be watching. We also have some breakdowns on MCQs and FRQs that are going to be really helpful for how to think through problems and how exactly to solve them. So without further ado, let's get to the lesson. Okay, so Unit 6, let's go. Unit 6, we're going to be talking about recursion, sorting and searching algorithms, and yeah, that's about it. This is the second to last unit that we're going to be talking about. Important note, recursion will not be on the FRQ section, so you can breathe a sigh of relief if you feel like this is hard. It'll only be on the MCQ section. In my test, I didn't get many recursion problems, but I think on other tests, some of my friends got a lot of recursion problems. So I guess it varies based on test to test. If you're taking the test in person, yeah, it might differ. So make sure to know these concepts, especially at least on a superficial level, so you can do the MCQ questions. For sorting and searching, I went through 5 steps to a Phi textbook, and they did have a sorting and searching question on the FRQ section, especially like the last question, which is dealing with arrays. So I'm not sure know these concepts, but for me, I kind of don't like sorting and searching because I prepared a lot for it because it was the concept that took me a lot to understand. And when I went to the test, there was no questions about it, so I felt like I wasted a lot of time just preparing for that. So for you, just be prepared for anything, and you'll do great on the exam. Just know this stuff, and I guess yeah, that's pretty much all I had as an intro. Let's get started with recursion to start off. Okay, so recursion is a concept that for many people is kind of hard to grasp. They're like a method calling itself. What does that mean? Okay, so I think of it as kind of like while loops. You know, when we talked about while loops, we have something like while int n less than 5, and we will have int n equals to 0, and something within this while loop has to be pushing n towards 5, right? So the same thing really applies to recursive method calls. You will have something called a base case. Okay, a base case is this case that the recursive call has to satisfy, and this is the case when the method breaks, when it stops, and when it actually ends the recursion call. You gotta be wary of infinite recursion, because if the base case is kind of not working and the method is not pushing itself to the base case, there's going to be something called infinite recursion. Just like within while loops, you had something called the infinite while loop. Within this, you get something called a stack overflow error, which means that the recursion is going to the point where the computer can't handle the data and it just breaks. Okay. In programming, programmers have to be really careful about recursion, and recursion is something that is not used that much in programming, especially because it's a more elegant way of doing things, but it's not essential. It's not necessarily the most efficient way to do things. So you gotta be extremely sure that recursion is the right way to go before you do it. Okay, so as I said, there is a base case, and to explain all this, I'm going to use an example. I'm sure all of you have heard of the Fibonacci sequence. If not, it's like this. It's 1, 1, 2, 3, 5, 8, 13, 21, so on and so forth. Okay, so if you don't get what's going on, each number is just being added to the one before. So it's 1 plus 0, then it's 1 plus 1, then it's 2 plus 1, then it's 3 plus 2, which gets 5, 5 plus 3, which gets 8, 8 plus 5, which gets 13, 13 plus 8, which gets 21, and so on and so forth. So what we want to do is we want to create a method that is going to take in a certain integer, and it's going to find that value of this sequence. Okay, so if we get 5, we want to get 1, 2, 3, 4, 5. We want to get to the 5th one, which is 5. Okay, so to write this method, we're first going to have to determine, first going to have to write this method. We will create a method. I'm going to write all this in pseudocode, so don't, it's not going to be Java, it's not going to be Java syntax, so damn, my computer's bugging out right now, but you know, we'll make it work. So, method called fib, and within this method, we're going to take an integer as an input. We're going to take an int as an input, And within this method, we're going to have a call. And the first thing we're going to have is we're going to have the base case. So the base case is written like this. We have if n equals to 1 or n equals to 2. So for n equals to 2, then we do something, so we return something or we break. We're not calling the method again, we're not calling fib again, we're just returning. So we'll return 1. Because, think about it, if n is equal to 1, that means if this an integer, so we'll make this int n. So if n is equal to 1, what is the number? It's 1. If n is equal to 2, what is the number? It's 1. And we want to get to the point where if it's going back, right, it's going to be this is going to be 8, 5, 3, 2, 1. So it's going to keep going back, right? And at a point, we want it to stop when it gets to the first value in the chain, okay? If this is a little bit hard to understand, I've written the full method in the overview, and you can go in there and, you know, do it and run it on BlueJ yourself just to see how it works. And you can use the debug tool to sort of see the process that are going on. And I think that would be really helpful for you if you're really struggling on recursion, okay? So we have the base case, and then after the base case, we have something called the recursive call, which is actually where the recursion is going to be happening. So here in this recursive call, we have the else statement. Obviously, if you did conditionals, you should know what I'm doing here. Well, I'm doing the if statement, and then the else statement, and then I'm return fib of n minus 1 plus fib of n minus 2. All right. Now this can be a bit complicated to understand. So let's do an example, okay? We'll do an example, we'll just think of any input. I'm thinking about 5, okay? The first thing the program is going to do is to check if n is equal to 5. Is it equal to 1 or 2? No, it's not. So fib of 5 is first going to return fib of 4 plus fib of 3. Plus fib of 3, right? Now we have fib of 4. Go back, it's going to check, is fib of 4 equal to 1 or equal to 2? No, it's not. So it's going to do fib of 4, or fib of 3, plus fib of 2. Now it's going to go here, because this thing still hasn't been resolved. It's going to do fib of 1. It checks if 2 or 1, it's not. So it's then going to check, it's going to get fib of 1 plus fib of 2, okay, because it's doing fib of n minus 1 plus n minus 2, okay, n minus 1 and minus 2, okay. Now it's going to check if any of these 1 or 2. Oh yes, we have got 1, we've got 1, and then we have got 1 over here. So we've got 1, 2, 3. Where are the remaining 2 going to come back? Oh wait, there's a remaining 3 here that has not yet become a 2 or a 1. So now it's going to do 3 minus 1, which is going to be 2, 3 minus 2, which is going to be 1. There we go. We have got 1 plus 1 plus 1 plus 1 plus 1 equals 5. At the end result, this will equal to 5. Let's go back and check in our sequence. What is fib of 5? 1, 2, 3, 4, 5. It's 5. We got the answer. Because recursion is kind of cracked, it is very complex. What this is called is a recursive tree. What I drew over here is a recursive tree. As you can see, it's looping down. It's getting 5, 4, 3, 2, 1. And then it's going down here. It's 3, it's getting 2, 1. And then to the point where it gets to 2 or 1, that part of the loop is cut off, and the remaining branches have to get down to 2 or 1. Okay, so the goal of recursion is to get to the base case. Every branch of the recursion has to get down to the base case before the method is called shut. Okay, and this is the analysis of the method. There is something called tail recursion, and I'm going to use an example that is given in the Barron's textbook. So if you have the Barron's textbook, you probably have seen this example before. It's the word play stack words thing, and that is pretty it's pretty cool, because if you have a list of words, you hold my hand and you input this into the program, it will return dot hold or dot hand my hold, because in recursion, if there is a line that is after the recursive call, so in this case the method is like this. So you have stack words, I'm gonna type this out because I think that it's an important method to get a hold of tail recursion. So stack words, and it takes okay, yeah, so we will just, so in the Barron's textbook, it gives you like a word, and that will be the input, and it's taking the user input. You can use the scanner class for this if you know what that is, but this will be the user input, and the user input has something like here, and then now we have the base case. So we have if word dot equals. If you're confused as to why I'm using equals, that is because for strings, you cannot use the operator equals to. You have to use dot equals because strings are a class and they have this inbuilt method. So for more extended information on that, I will be talking about that in the next unit, which is unit 7, and I'll go into the string methods in depth. So we have if word dot equals to this dot, the period, we print line. So system.out.print line, and we print nothing. All right, now else, what do we want to do? We want to just call stack words again, and essentially what this is going to do. And then after this line, let's say we have another line. It's a system.out.print. I'll just say word. So first word will be the first word will be hold. Okay, now hold gets put in this stack type thingy. It's at the bottom of this. It's at the top of the stack. Okay, the first time it's there, it's at the top of the stack. Next word it's going to read is my, but now my gets put at the top of the stack, and then hold gets pushed one level lower. Third word is hand. So now my gets pushed down. We get hand, my, hold, and then suddenly you get period, and period is printed, but it's reached the base case because as of here, the base case is if the word is equal to period, and suddenly it gets cancelled. We get dot, hand, my, hold. Then suddenly this is what is printed as the output. So in tail recursion or stack recursion, what is happening is that there will be a little line here. This line is after the recursive call. If that is happening, that line is going to get put in a stack, and it's going to execute that line from top to bottom. Okay, remember this diagram that I've drawn. Okay, that really helps me out whenever I think about stack recursion, thinking about each level getting pushed lower and lower, and then suddenly you just print everything straight down. Okay, cool. Now let's go to sorting and searching. Okay, sorting and searching as a concept, they're pretty simple to understand, but when questions are asked about it, things can get sort of complicated. Let's first talk about sorting. Now, sorting has to do with arrays. Or both sorting and searching have to do with arrays, but in this one, let's say you have an array of 3, 1, 6, 4, 9, and this is the array that we are going to be looking at, and it's already been defined. Sorting deals with how do you sort this in a certain order, like how do you sort it from smallest to largest or largest to smallest. So the output, if we want to create a method for this, the output should be something. If we want to do it from smallest to largest, it should be 1, 3, 4, 6, 9. And if you want to do it largest, it would have to be 9, 6, 4, 3, 1. Right? So we need some method to do this, and that's what sorting is. And you have some of these specific types of sorting that allow you to do it in certain ways. The first thing is selection sort. So selection sort, what it does is that it will take the smallest value and place it in the front, and it'll keep doing that until all the values are sorted. So it'll first take, in this one, it's 3, 1, 6, 4, 9, right? So first thing it'll look at, let me highlight the portion of the loop that it'll look at. The first time it looks at all of the loop, okay? And when it's looking at all of the loop, the smallest value is this 1, so it gets put in the front. So these two swap. So it does it by swapping. So it'll be 1, 3, 6, 4, 9. And suddenly it now looks for the smallest thing again. And suddenly this time it's only looking for this one. So the length of the portion that it's looking at decreases, because now this thing has been sorted correctly, but the rest hasn't. Now the smallest variable is 3, but it's already there, so it's not going to do anything. Now it's 1, 3, 6, 4, 9. Now what does it look like? It looks at these three values, and it'll sort these three values. It'll get 1, 3, these two switch positions. It will get 4, 6, 9, and then as of right now, we know that it's sorted correctly, but it doesn't know that, so it's going to do it one more time, and it's going to check, are these two sorted correctly? Yes. And it's going to check for the final one, is it sorted correctly? Yes. So selection sort is pretty inefficient just in terms of sorting. That's why we have other methods, other ways to do it. We have insertion sort. So insertion sort works a little bit differently. So insertion sort, what it does is that it inserts a variable into the sorted list. So an example would be for the thing that we're looking at. What is the final thing? So is it 3, 1, 6, 4, 9? Okay, 3, 1, 6, 4, 9. So first it will look at these two variables, and then it will do 1, 3, 6, 4, 9. Then it looks at these two variables. Yeah, it compares these two variables, and then suddenly it will look at the final two variables, and it'll do the same. So these two variables, 3 is less, so it works. With these two variables, 4 is less, so it gets shifted. So it'll be 1, 3, 4, 6, 9, and the remaining two variables, they are fine. So with this insertion sort, as you can see, it's a little bit different just in terms of how it works, and yeah, that's pretty much it. I have explained insertion sort a little bit better in the overview for Unit 6, so make sure to go and check that out. Last one is merge sort. Merge sort uses recursion. It's not really that important to know what merge sort is. I don't know what merge sort is, really, truthfully, if we're being honest. I still don't know what exactly it is, but all that you need to know is that it uses recursion. It sort of splits the list in half, and it sort of keeps splitting them in half and then combines them, and suddenly you have a sorted list, I guess. I'm sure there are videos online that can teach you about merge sort in more detail. If you are interested about it, definitely go check it out. But in my opinion, it's not that big of a concept. You'll be fine not knowing it for the AP exam. Okay. Second thing we're going to talk about is searching. We have sorting and we have searching. So searching is, let me give you an example. So let's say you're going on Amazon and you enter a search for I don't know, a Rubik's Cube. So you enter a search for a Rubik's Cube. Amazon has a list of products, and it has to find this Rubik's Cube product that you're searching for. So this list of products, think of it as an array, it has to go through the list and find the correct Rubik's Cube that you are searching for. So how will you do that? Will you go through each value and check if it's equal to the Rubik's Cube? Maybe. Or will you use a more efficient way to do it? Now the first way is sequential sort, sequential search, okay? Sequential search, what it does is that it takes every value in the list. So let me give you an integer list. So let's say you're searching for int equals to 5. So we have a list that is 1, 3, 6, 4, 5, 3. So what sequential search will do is that it will check each value, and it will check if it's equal to 5. Is 1 equal to 5? Is 3 equal to 5? Is 6 equal to 5? 4 equals to 5? Is 5? Yes, it equals to 5, so it returns that, and you have the position. Okay? The worst case scenario for this is that if somehow the integer value that you're looking for is at the very end, it's going to have to check every value up to the end, right, before it finds it. Or even worse, if it's not in the list altogether, then it doesn't make any sense. The next way that you can do this is called binary search. Now, binary search is a concept that is uses recursion. So pretty much, let's say we're using the same list: 1, 3, 6. What was that? Was that a 9? 9, 5. Bro, my handwriting is whack. I literally can't. Okay, I'm just gonna change it. 4, 5, 9. It's fine. Okay, so the midpoint. The first thing it does is it finds the midpoint of the list. What is the midpoint? How many? 1, 2, 3, 4, 5, 6. So at the third place is the midpoint. It finds the midpoint and it checks, is that greater than or equal to, for binary search to work, I made a mistake. For binary search to work, the list has to be sorted from smallest to largest. So let's do that. So 1, 3, 5, 7, alright, we'll do 6, 7, 9. Okay, so for binary search, scratch everything I said before. Binary search needs to have the list sorted from smallest to largest. Okay, that's the only way it'll work. So first thing it does is it finds the midpoint, which in this case will be 5. That'll be the third value, so it'll be 5. and it will check is 5 greater than, less than, or equal to the value that you're looking for. So in this case, we're looking for 5, so it's pretty convenient that this is 5, so it'll just return 5. But let's change this value to be something like, I don't know, 7. So is 7 greater than or less than 5? It is greater than 5, right? So that means that it disregards this entire portion of the list because all of that is less than 5, right? And it only focuses on this portion of the list. Now it takes the midpoint of this portion and checks if it's greater than or less than 5. In this case, the midpoint of this portion of the list is equal to 7. So there you go. You have your answer, okay? That's how binary search works. It keeps splitting the list in half. So it'll split the list in half here, split the list in half here, and if that's not the case, it checks if the last value is this. So when lists are really big, binary search is a much more efficient way to do it than sequential search. There are many questions on the AP exam that might be binary search, so a key way to look at it and see if it's binary search in the MCQ section is for variables like low, mid, and high. If you see those variables, that should immediately that was a terrible highlight choice. But if you see these variables, that should immediately signal to you that you are going to be dealing with binary search. Okay, so this unit is going to be one of the harder units in AP CSA. It's going to be involving a lot of conceptual understanding of these things, but good news, chances are you won't encounter a lot of these on the AP test. But if you know it and you know it well, if you already encounter a problem, you'll be well prepared, okay? Make sure to go check out the overview. Make sure to go and, if you're on my YouTube channel, go check out my Thinkific course. If you're on my Thinkific course, thank you again for supporting me. And that's pretty much it. If you have any questions, write it below in the comment section or email me at aditya@gmail.com. And yeah, make sure to have a great day. Peace out, guys.